Okay, group. Today we're looking at exponent rules. Yeah, we're going to review all of our old exponent rules that we'll need for our new unit here. Okay, so let's start with the basics. Okay, remember, if we multiply like bases, so if I have x to the m times x to the n, that's x to the m plus n. Remember, multiply like bases, we add the exponents. Okay. Divide. Remember, we're dividing, so it's x to the m divided by x to the n, then it's x to the m minus n. We're subtracting. Okay. Also, remember, if you have if it's a fraction in the form of a fraction for division, if I have like x to the n over x to the m, okay, we can write this two different ways. We can write this as x to the n minus m, or we can write this as 1 over x to the m minus n. Okay, I always look at these and say, okay, I always subtract my bigger number from the smaller number to avoid negative exponents. Okay. That's right. Let me do one more rule. Then we have two more rules here of review. So it's dividing, multiplying, power to a power. Okay, so if I have like x to the m times x to the 8 times x to the n, all of that raised to the p power. Okay, then we multiply. Right, multiply. So it's x to the mp. Oops, let me put this as a y. Y to the np. Okay, you have to distribute, multiply it out. And then negative exponents. Okay, so if I have x to the negative m power, that is equal to 1 over x to the m. So you have to remember to flip the base. You have to flip the base. Okay. Okay. And by the way, power to a power is literally this rule right here. Adding exponents. Okay, so if I wrote this thing out p times, I would have p times m of the x's. Okay. All right, let's look at this, our first example. In our first example up top here, I have a negative exponent I have to deal with on the outside of the parentheses, and I have all this stuff on the inside. I cannot multiply these two until I take care of this negative exponent. Okay, so I literally have to do 4 to the negative 3 power. Okay, that's a negative 3. 4 to the negative 3 is literally, I'm going to put a fraction bar, 1 over 4 to the power of positive 3. So that is 4 to the 3 is 64. Then I have a to the negative 3rd power. And, well, I know a to the negative 3rd needs to become a 1. Actually, excuse me. I'm going to write it out as a to the negative 3rd, and then I'm going to write b to the 6th power. Okay. Actually, yeah, I'm going to leave it. So then I have my 3, a to the negative 2, b to the power to the 3. Yes, these are all over 1. So now I just have to multiply. 3 times 1, 3. So I have 3 over 64. Then I have a to the negative second, and a to the negative third is a to the negative fifth. So it's times a to the negative fifth. Because I'm adding exponents, and I have b to the power of 9. And now I just have to clean this up. And I have a to the negative fifth becomes 1 over. So then I have big giant fraction bar. I have a 3 over 64. Then this goes down. And then I have b to the 9th on top. Okay, done. Yes, there are other ways of doing this. Okay, I just sort of broke it down. I'm not crazy how I wrote this out here, but we're done with the answer. All right, let's look at this new one. I'll make sure I do it better. So I have to 4 to the second, 16, a to the second, a squared, b squared to the second, so we're going to multiply 2 times 2, and then c to the negative 10. Then I have 2 to the negative fourth power, so that is 1 over 16. Then it's a to the positive 8, and then b to the negative 4. Okay, 2 to the negative fourth, you can easily type that into your calculator, your graphing calculator, and then do math frac, okay, math enter, enter. Or you might be able to do it in a good scientific that can change it to fractions. Okay, let's see on this one. Can I do it on here? So 2, let's see if I can, I should be able to do it on here. 2 x raised to the y key negative 4 hit equal, and it gives me this decimal. I should be able to change that decimal to a fraction. It's right here, I believe. Yep, 1 over 16. Okay, now I'm going to worry about taking care of all my other issues. So I got to multiply these still. We're still multiplying. So I have 16 times 1 over 16, that's 1. A squared times a to the 8th, that's a to the 10th. Remember, all I'm doing is taking care of these things in alphabetical order. B to the 4th times b to the negative 4. Right, that's b to the 0, which is 1, so they're gone. They cancel out. And now I'm left with c to the 10th, negative 10. And now where do I take care of the negative exponent? They go down. That has to go down. So it's, I have a to the 10th over c to the 10th. Oh, that's a rule I left out. Anything to the 0 power is 1. Okay? That literally comes from your subtractions. That comes from division. Okay, so if I had like a to the third over a to the third, we know that's equal to 1. Well, the exponent rule tells you to subtract. N minus m, you get 0. So anything to the 0 power is 1. But it comes from division. So the power to a power is our multiplication rule. Negative exponents in the 0 power is division rule. All come from the division rule. All right. Look at this big ugly mess. Some people say, oh, you got to move everything around, make them all positive exponents. I don't bother doing that. All I do is follow my rules. Follow your rules. Your rules. Oh, I got to reduce 10 and 6. So I can reduce those each by 2. So I have 5 over 3. Now look at this. This says a to the negative third, and this is an a. I'm going in alphabetical order, taking care of my letters. Now I'm going to do my subtraction. I'm not going to say, oh my God, this is a negative exponent, I don't know what to do. No, follow your rules. You're dividing. What does division tell you to do? We have to subtract exponents. Okay? And then what I also say is, where's the bigger exponent? That's right, 1 is bigger than negative 3. So you're looking at 1 minus negative 3. Right, that's 4. And where do you put that? That's on the bottom. Your bigger exponent is on the bottom. When you do your subtraction, you leave your answer on the bottom. So it's a to the power of 4. Look at that, no more negative exponent. B squared, b to the negative third. Which one's bigger? 2 is bigger, so that means the result goes on top. So it's b on top. Now I just have to worry about my exponent. That's right, that's a 5. How'd you get 5? It's 2 minus a negative 3. That's all you have to do. Follow your rules. The rules say to subtract. All right, c to the negative fifth, c to the negative 6. Which one's bigger? Negative 5 is bigger than negative 6. So it's c is on top, and now I have to subtract. Negative 5 minus a negative 6. That's right, I get 1. So c to the first. I'm done with it. Look at that. I didn't have to, oh my God, I have to change everything around. No, follow your rules. The rules will tell you what to do. All right, up here. I'm going to take care of this negative exponent. Then I'll take care of the top. Then I'll reduce with this at the bottom. So this is multiple steps in here. Big ugly mess, but it's just your rules. So start off by saying 2 to the negative 2 power. So that is 1 over 4. Then I have a to the third, and to the negative 2 power, that's a to the negative 6. And then b to the negative 4 times 3a to the negative 1. Okay, now I'm going to take care of the top. Okay, I'm going to take care of the top here. Where am I going to do this? I'll put it over here. So I have 1 over 4 times a 3, so that's 3 over 4. Then I have a to the negative 7, right? Negative 6 and a negative 1, and I have b to the negative 4. Now, how do I take care of this 4 up here? Look at that. It's 3 over 4 over a big 4. That's right. It's a complex fraction. All right, multiply top and bottom by 4. Actually, you can just put this 4 down below here, and it's done. So multiply by 4. So I have 3 on top, 16 on the bottom. All I did was multiply top and bottom by a 4. Well, let me do that in another color. There. So those cancel, and I have 4 times 4. All right, a to the negative 7 and a squared. Which one's larger? That's right, a squared is bigger than a negative 7. So it's a is on the bottom, so it's 2 minus a negative 7. So a to the 9th on the bottom. And negative 4 and a positive 3, which is larger? Remember your b's. Okay, so that's right, it's a to the 7 on the bottom. How'd I get that? 3 minus a negative 4. There we go, problem's done. Follow your rules. Notice what I did. I did not freak out with negative exponents. All I did was follow my rules. Okay, look at number 5. How am I going to multiply this together? Right, we only can multiply when the bases are the same. But from last year, what do you know about 27 and 81? I can make them have the same base. That's right. 27 can be rewritten as 3 to the power of 3. Times, and 81, that's right, 3 to the power of 4. Now, notice how the bases are the same. So I made the bases the same. Okay? I mean, if 27 and 81 did not have a common base, we would not be able to do this problem. The only way that we could do this is because I know 27 and 81 are both powers of 3. 3 to the third is 27, 3 to the fourth is 81. Now my bases are the same. All right, so first of all, what do I do with this 3 next to this exponent? That's right, we have to multiply. So this is 3 to the 3n plus 3 times 3 to the 4n minus 16. And now the bases are the same. And then what do we do with exponents? That's right, we add 3n. Oh, I'm sorry, 3n. I'm not going to show it all work. I'm just going to do it. 3n and 4n is a 7n. And then I'm adding 3 minus 16 is a negative 13. There we go. We just did the problem. You had to get the bases the same. Bases the same. Then we had to multiply. Power to a power, multiplied. And then we kept the base. We added exponents. 3n and 4n is 7n. 3 minus 16 is negative 13. Okay? Oh, look at the wackiness back here. All right, 1 over 6. I can 2 to this 216 is a power of 6. So that is 6 to the power of 3. This right here is 6 to the power of 3. So let me rewrite. I'll rewrite over here. So I have 1 over 6 to the 3n minus 1. Then I have times 1 over 6 to the third power. Oop. All of that to the 4 minus n. Okay. Now notice I'm leaving these as fractions. I probably could have changed these to a whole number. If I were to change these to a whole number, what would I do? That's right, this would have been written as 6 to the negative 1 power. And then this would have been written as 6 to the negative 3 power. Okay. Usually we would write things with a not a fractional base, but with a whole number base. So this is what we need. We would need these as a whole number base. So this is okay, but we're better off writing them with whole number bases. People don't like fractions for some reason. All right, so then I have to distribute the negatives, distribute the negative. So I have So I have 6 to the negative 3n plus 1 times 6 to the negative 12n plus, oh, there's no n on that. I wrote this one backwards. Negative 12 plus 3n. All right, now all I have to do is just combine likes. So I have 6, let's see, oh, negative 3n and a positive 3n, they cancel. So I'm left with 6 to the negative 11 power. I'm going to leave it like that. I mean, if my direction said no negative exponents, so then I would have to flip this. But right now I'm going to leave it just like that. There's nothing wrong with that for right now. Okay. Now let's take care of this one. Now notice, look at all my bases. These are whole numbers and this is a fraction, so I'm going to get them all whole number bases. Right, what power are we going to use? Right, can't use 4. There is no nice power of 4 to equal 8. It's a fraction. I don't think you want to come up with a fraction. Okay, same thing with 32. There's no power of 16 to equal 32. All right, so we're going to have to go smaller. We're going to use power as a 2. We're going to change all of these to powers of 2. So 2 to the 5th n times 2 to the 3rd 1 minus 3n over 2 to the negative 4 times 2 squared. I think what I'm going to do is take care of the tops, then worry about the bottoms. So on the bottom, I have 2 to the negative 4n times 2 to the 2nd. Then on the top, I have 2 to the 5n times, I'll make sure you guys can see this, 2 to the 3 minus 9n. So I'm just using my rules now. And I'm going to take care of the top, take care of the bottom, then I'll worry about division. So the top is, right, we have to add, so I'm collecting likes, so it looks like I have 2 to the 3 minus 4n, right, adding 5 and the negative 9. And then down below, I have 2 to the negative 4n plus 2. Well, actually, I'm going to write it the same way. I'll put the negative in the back. So I'll write it as 2 to the 2 minus 4n. Okay. All right. Now we have to do our division. And how do we divide? That's right. We have to subtract. I'm looking at my values here, and I'm going to say that this top is bigger because this, negative 4n, those are the same. 3 is bigger than 2. So I'm going to put this on top. I'm going to bring it up. So it's going to be 2 to the power of. And what are we going to be doing with these two? That's right, we're going to be subtracting them. So I'm going to write it out somewhere so I can subtract them. 3 minus 4n minus the quantity, 2 minus 4n. So 3 minus 2 is 1. Negative 4 minus a negative 4. Well, those cancel out. So we're just left with 2 to the power of 1. That's it, 2 to the power of 1. Well, I know. A lot of work in there, but all we did was use our exponent rules. We changed the base, power to a power, and multiply. And when we multiply like bases, we added. Okay? And then we division, we subtracted exponents. Okay? That wasn't bad. All right. Let's look at this one right here. Do my directions say positive exponents only? Of course, expressed in simplest form with positive exponents. So all of these have positive exponents. Okay. So this right up here should be written as 1 over 6 to the 11th. Which if we would have left it in fractional base would have gotten there faster. Oh well. Okay. Uh-oh. Radicals. Oh, there's our last rule of the day. Okay. How do we take care of radicals? We have to change radicals to exponents. Okay. So that's this rule right here. That's your fractional exponents. Okay. Fractional exponents. The nth root of x is equal to x to the power of 1 over n. Okay? You read this, this whole thing is read the nth root of x. That's how we read it. This right here is read as an ordinal number. Ordinal numbers like first, second, third, fourth, fifth, sixth, so on and so forth. Okay? That's an ordinal number. Okay, so that's a fractional exponent. And now, where'd this 1 come from? That's right. The exponent on this x is a power of 1. Okay? Well, what if this exponent was not a 1? Well, then, let's do the nth root of x to the power of m. Right. This is the root right here. That root is the denominator of the fraction. So we know it's a fraction. So this is the denominator, and that's the numerator. M over n. That's your rule. Okay? So how do I rewrite this? Cannot multiply them as they are right now. We have to change these to fractional exponents. Okay, the first thing we have to do is change to fractional exponents. So this is x to what power? Right, to the 2 over 5 times, what's this? Oh, what's the number that's not showing here? That's right, it's a 2. This is called a square root. Okay, this is called a fifth root. This is a square root with no number showing. So this is x to the 3 over 2. Okay, you do not need to put a 2 here. Some calculators have put the 2 there now automatically, but you do not need to put a 2 there. Okay, on this old calculator here, there's no 2 there. It is just called a square root. That is called a cube root. Okay. All right, multiplying like bases, what do we have to do with the exponents? That's right, we have to add. Okay. Now, some of you may have a calculator that can add fractions. Well, then pull it out and use it. If not, you're going to have to add fractions the old-fashioned way. Okay? I have to have a common denominator. All right, I have to multiply this one by 5. Oh, no. I got to multiply this by 2 and this by 5. So I have x so top and bottom by a 2 here, so I have 4 tenths plus 15 tenths, so I have x to the 19 tenths. Okay? And I know some of you are like, how did he add fractions? Well, okay, all you got to do is pull out your handy-dandy calculator. On this calculator, I have this thing called an ABC key. Okay, that ABC key is a fraction button. So I have 2 fifths, so 2 ABC 5, 2 ABC 5 plus 3 ABC 2, 3 ABC 2. And then when I hit equal, it changes it to a mixed number. And you see this thing on my scientific calculator is D over C. That's improper. So all I have to do is hit shift and that. There's 19 over 10. Okay? If you have your graphing calculator, you can just do math, enter, enter. You don't even have to do the fraction button. You can just do, 2 divided by 5 plus 3 divided by 2, and then just do math, enter, enter. Or you can just add the fractions up on a piece of paper. Not that hard. Oh my Lord, look at all of these wonderful radicals. Okay, so what do? First thing we gotta do is change them all to fractional exponents. Oh, fractions are fun. X to what power? All right, that's 1 over 3. This is called the third root. This is called the sixth root. Times x to the 5 over 6. And then I have, all right, that's called square root, so it's x to the 1 over 2. Okay? So I'll start by adding these up. So that's right, I want to multiply top and bottom by a 2 here, or else you can just type it right in your calculator. Well, what are you going to do? Right, we would add these two together and then subtract. If you have a negative exponent, put it on the bottom. If you have a positive, put it on top. That's all. Since you don't have your handy-dandy calculator, you got to show all your work. But you should see something like this. You should be able to type it right into your graphing calculator. Okay, 1/3 plus 5 over 6 minus 1/2. And if your fraction's negative, then you put it to the bottom. You would do 1 over your answer. If it's positive, then you just leave it on top. That's it. Okay, so I'm going to get all these denominators the same. Look at that, there's a 6 here, that's 2. I'm going to multiply this by a 3. So then I can do all the work, I don't have to worry about it afterwards. So I have x to the 2 over 6 times x to the 5 over 6 times x to the 3 over 6. So I'm going to add those up and then subtract 3. So that 2 and 5 is 7, minus 3 is 4. So I am looking at x to the 4 over 6, and then you're in pre-calculus, so that is x to the 2/3 when it's all said and done. Okay? If this was a negative 2, well, I would have, if this was negative, I would have had it on the bottom, but I would have seen that. I would have seen that once I did 2 plus 5 minus 3. So I'll get all your denominators the same, boom, do your work. It's not that hard. All right, so we got a couple extra steps here. You see this, all of this raised to the power, we cannot just multiply here, okay? We have to fix these first. We have to rewrite everything in fractional exponents, then we'll do our squaring, okay? Or we'll combine, then square. It's up to you. So I have, what's this? 2x to the 2 over 4 times x to the 1 over 3 over x to the 5 over 6 times x to the 1 over 3, all of that squared. I could distribute the 2 to each of these, or else we can combine these fractions, then multiply by 2. Okay? I think what I'll do is I'll combine these. And actually, I think what I'm going to do is I'll do the stuff inside. I'll follow order of operations. So I'm going to take care of the stuff inside first. So I have to multiply these. I have to multiply this by 2 in here. So I can add these two fractions together. So I have x to the 2/4 times x to the 3rd over, that is now 2 over 6, right? That's x to the 2 over 6. So I have x to the 7 over 6, all of that squared. I think what I'm going to do now, I'll multiply this together, and then I'll worry about common denominators. So I have x to the 2 over 4 times x to the 3rd all over x to the 14 over 6. Okay, all you do is just 2 times 7. That's it. Actually, no, I'm going to do this. Since I'm multiplying here, I'm going to write x to the 7/3. How did I get 7/3? That's right. 2 goes into 6 3 times. All right, nice and neat over here. So I have, look at this, 2 over 4. What can we do with that? Let's try. I'm going to reduce it. So I have x to the 1/2. You don't have to do that. Actually, you guys probably would not be doing that. So x to the 2 over 4 times x to the 1/3 over x to the 7/3. Right. What's our common denominator? 12. Ooh, why did I, oh, that's in the way. Oh, well, of course it's in the way now. Let me slide this up. I can finish it down here. So what's our common denominator? Right, we're going to have to multiply this by a 3, these by 4s. So we have 8 over 12, 4 over 12, 28 over 12. So, right, 8 plus 4 is smaller than 28. So we have 12 over 28. So my answer is going to be on the bottom, 1. And I have x to the 14 over 12. 16 over 12. 8 and 4 is 12, minus 28 is 16. So I have 16 over 12. So that becomes 1 over, and I can reduce that to, let's see, 4 goes into both of those, 4/3, x to the 4/3. It's just an exercise in fractions, okay? Again, you know, with your handy-dandy graphing calculator, you can do all these fractional work on the calculator, okay? So you don't need to make this big, long, drawn-out, oh my God, I can't add and subtract fractions. Well, guess what? You're in pre-calculus. Figure it out. use your calculator or else do it. It's not that hard. All right, folks. We did a whole bunch of exponent rules. Okay? All right, have a good day.